After 4 years of research and development, Tesla's humanoid robot is closer than ever to resembling humans. The sales of its initial versions could disrupt the tech market, with a bold target of producing 1 million Optimus units by 2025. Musk's plan to overcome manufacturing barriers has amazed the world. Additionally, advancements in AI are driving ambitious ideas for humanoid robot development by Figure AI, as they recently announced plans to launch their humanoid robot this year. So, how will Elon Musk tackle these challenges? Should Tesla pay attention to the technology of its competitors? That's what we'll dive into in today's episode. And welcome to Techno Creators. Before we begin, please help us reach 3,000 subscribers. It will be a huge motivation for us to continue bringing you great tech episodes. How groundbreaking is Tesla Optimus Gen 3 compared to the Figure AI? Designed to mimic the human form, walk on 2 legs, and handle manual labor, Figure's humanoid robot currently relies on real-world human input. With millions of jobs unfilled in the United States, Figure's humanoid robot is designed to take on tasks people might not want to do or lack the skills to perform. It is envisioned to handle more advanced duties, such as elderly care or even cooking. This concept sounds quite familiar. In 2021, Elon Musk shocked the world by unveiling plans to build an AI-powered humanoid robot. Initially, skepticism dominated, fueled by the sight of a dancer dressed as a humanoid robot performing on stage. However, with the debut of Tesla bot Bumblebee, Musk's promise became a reality. Tesla's latest revelations provide a glimpse into Optimus's movement, from lab testing to navigating real-world uneven terrains. Demonstrating flexible strides, Optimus significantly outpaces Figure with longer and sturdier steps, visible by over half a foot in stride length. Meanwhile, the Figure bot's sequential steps fail to achieve truly natural motion. In practice, Optimus can move at a speed of 0.6 meters per second, a significant improvement following Tesla's announcement of a 30% speed increase for the robot. Each time a robot's foot touches the ground, a force is exerted. The stiffness increases with the straightness of the knee, causing vibrations to travel to the joints, making the robot's movements less natural. Humans do not face this issue because we have ligaments between our joints that absorb shocks upon surface contact. Tesla has nearly solved this issue through 3 major updates. Initially, the Bumblebee version exhibited unnatural strides. In the first update, Tesla demonstrated a solution by enhancing in-house manufactured actuator components, eliminating the need for external suppliers. Tesla claimed significantly improved balance capabilities, with greatly enhanced whole-body control, enabling the robot to perform actions like squatting with ease. The drivetrain system converts input signals into the actual force needed to power everything from the robot's feet to the delicate movements of its fingers. It appears that startups in the humanoid robot industry are creating something similar to the first generation of the Tesla bot. An intriguing aspect of Figure AI is that none of the company's founders have a technical background. Notably, Brett Adcock, one of Figure AI's founders, previously established Archer Aviation, an aerospace company that developed electric vertical takeoff and landing aircraft to enhance urban mobility. Brett successfully built Archer into a leading global electric aviation company, raising over $1.0 billion in funding, taking Archer public on the New York Stock Exchange with a valuation of $2.7 billion and securing a $1.5 billion commercial deal with United Airlines. However, the company ultimately failed to deliver any products to its partners. This raises skepticism about the significant investments from tech giants like OpenAI, Microsoft, and Nvidia, which appear to be echoing a similarly ambitious but unfulfilled precedent. Don't forget that Tesla is an electric vehicle manufacturer with over 5 million EVs on the road, all equipped with AI systems to collect real-world operational data. They leverage 25,000 NVIDIA GPUs to power their AI infrastructure, particularly the Dojo system, a supercomputer with 1.8 exaflop of processing power, which is used for training autonomous driving systems and other AI models. This is the biggest and most challenging issue in humanoid robot manufacturing, and it's why Tesla can confidently take on this task. Robots need to integrate sensory inputs in 4D, model their environment and their place within it, identify the goals they want to achieve, decide how to move toward those goals, plan their motions, and interact with humans and objects. Afterward, they must send commands to the motor control system to determine how to move the actuators, controlling the robot and manipulating its limbs to interact with objects in its space. Ideally, these movements should mimic human-like motions to ensure a pleasant experience for observers and avoid triggering the uncanny valley effect. The humanoid robot market is becoming increasingly crowded, with numerous companies researching and developing new models, making the market more diverse than ever. Some of these could become competitors to Tesla Optimus, while also providing us with more options for the future. Let's explore the three most notable humanoid robots beyond Optimus and Figure AI currently on the market.
1. Atlas Gen 2. If Tesla says Optimus is made for tasks that are unsafe, repetitive, or boring, Boston Dynamics says its Atlas is made for tasks that are dull, dirty, and dangerous. And they're here to augment people or to do the jobs that most people don't want to. So how did Boston Dynamics create their Atlas Gen 2? On April 17th, one day after posting a farewell to their old version HD Atlas, Boston Dynamics introduced a new all-electric version of its humanoid machine. The next-generation Atlas robot, with 1.5-meter height and 89-kilogram weight, is designed to offer a far greater range of movement than its predecessor that can keep a humanoid form without limiting how a bipedal robot can move. We've designed the electric version of Atlas to be stronger, more dexterous, and more agile. Atlas will move in ways that exceed human capabilities, the company said in its press release. The original Atlas robot can do a range of tasks, including lifting objects and even busting out dance moves like Parker. The company said that its new all-electric model will break new, bigger ground. The electric version of Atlas will be stronger, with a broader range of motion than any of our previous generations, improving the drawbacks of the last model significantly, especially noise, fluid leakage, complexity, and high cost. The teaser showcasing the new robot's capabilities is unnerving. The design itself is also a little more humanoid. Similar to bipedal robots like Tesla's Optimus, the Atlas Gen 2 now has longer limbs, a straighter back, and a distinct head that can swivel around as needed. The longer limbs, both Optimus and the new Atlas have longer limbs compared to their predecessors. This elongation enables them to have a greater range of motion and reach, which is essential for tasks requiring manipulation and mobility. It is considered that the robot can totally exceed human performance. Straighter back in the new Atlas provides several benefits, including improved stability and posture. This design modification enables better weight distribution and balance, contributing to the overall agility and efficiency in movement. Distinct in head with swiveling capability, both robots now feature a distinct head component that enhances their perception and interaction capabilities. This head can swivel around, allowing for greater flexibility in visual perception and communication. Optimus's previous model might have had limited head movement with a swivel range of 90 degrees. In contrast, the new Atlas can swivel its head up to 180 degrees, expanding its field of view and enabling better situational awareness. The biggest highlights is that its face includes a built-in ring light and its head resembles a makeup mirror. This robot can move quickly and flexibly. The only downside is its shape is still a bit jerky, but it's completely different from the hydraulic Atlas. Moreover, there are no cables in sight, and its face includes a built-in ring light. It's a marked improvement on its predecessor and now features a bunch of Boston Dynamics' new AI and machine learning tools. This new model will be tested with a group of customers over the next few years, starting with Hyundai. It's expected to be at the core of the transition to build the next generation of automotive manufacturing capabilities.
2. Unry H1 Evolution Gen 3.
Founded in 2016, Unry is a Chinese company that has already created many innovations in robotics and established itself as one of the top players in hardware AI. The company recently revealed the first-ever general-purpose humanoid robot named H1 Evolution v3.0. It comprises composite and lightweight materials such as PLA, PETG, nylon, and resin. The size of this robot is about 180 centimeters and weighs 47 kg and can carry a load of up to 30 kg. The company equipped the robot with a 3D LiDAR and depth camera, which helps to do panoramic scanning of 360 degrees, combined motors, core motion module, and hollow electrical routing. These advancements give real-time data about the surroundings, enabling walking and running autonomously in complex terrains and environments. Regarding mobility, the robot also holds a world record with a moving speed of 3.3 meters a second and a potential mobility of more than 5 meters a second shortly. This is equivalent to the running speed of a human, 5 times faster than Tesla's Optimus with a speed of 0.6 meters a second and 0.8 meters a second higher than the figure for Atlas Gen 2. In 2022, bipedal robot Cassie from Agility Robotics set a sprint robot record by completing a 100-meter dash in 24.73 seconds, an average speed of 4 meters a second or 14.4 kilometers an hour. However, at that time, Cassie looked quite basic with a pair of legs and a head, not yet considered a complete humanoid robot. H1 is not only capable of moving quickly, but can also perform complex dancing movements, demonstrating dynamic synchronization and powerful landing abilities. This is a notable step forward in the field of humanoid robots and shows the significant development of robotica technology. For endurance, Unry has installed a battery with a capacity of 846 watt-hours, 250 times that of the iPhone 15, with a quick replaceable option. Unry outfitted the H1 with AI for better communication with humans, allowing the robot to analyze the commands better. Not stopping at the ability to move quickly, H1 once attracted attention when demonstrating the ability to self-balance, move in complex terrain, can withstand strong kicks from humans, and carry heavy objects. Evolution v3.0 also demonstrated the skillful ability to climb stairs up and down in many directions, dancing to music. It also coordinates the whole body when jumping up and down. Some experiments show that it can jump as high as a human. According to analysts, the standing jump is more important than a performance because it shows that H1's legs can coordinate with other parts smoothly and maintain perfect balance thanks to the motorized leg operation M107 electric motor is produced domestically in China. Each leg has 5 joints distributed in the hips, knees, and ankles. The arm has 4 joints located at the wrist, shoulder, and elbow. Boston Dynamics Atlas Gen 1 can also perform jumps, but still uses bulky hydraulic actuators. Therefore, creating legs like Evolution v3.0 is considered a step forward for the robot industry, demonstrating the high competitiveness of this robot. Unry's robot costs up to $90,000 US, and if you want to own it, you have to book in advance and wait 3 to 10 years.
3. Kepler Forerunner.
Could you tell me what stands 178 centimeters tall, weighs 85 kilograms, and has 5-fingered hands with 12 degrees of freedom and a total of 40 degrees of freedom throughout its body? That's right, it's the Kepler Forerunner humanoid robot. Manufactured by China's Kepler Exploration Robot Company, the Forerunner is designed to be the strongest direct competitor to Tesla's Optimus robot because it's powered by technology similar to Tesla's product, utilizing planetary roller screw actuator and rotary actuator technology for sophisticated movements and control. However, it is a bit more expensive than the Tesla bot. Whereas the latest price estimate for Optimus is less than $20,000, the Forerunner ought to go for about $30,000. One of the robot's big selling features are the proprietary planetary roller screw actuators in its arms and legs. These deliver up to 8,000 newtons, about 1,798 pound force of thrust to the elbow, knee, and ankle joints. According to Kepler, these actuators surpass conventional motors in delivering precision control, enhanced power, and quick responsiveness, adeptly handling complex tasks. Custom rotary actuators move the waist and shoulder joints. The Forerunner perceives its surroundings via a group of sensors located in its head. These devices include a wide-angle binocular camera, a far-field array of 4 microphones, and an accelerometer and an AHRS, that's Attitude and Heading Reference System. It can also speak to people via a synthetic voice module and stereophonic speakers.
Wish you all the best.
All of the sensory data is processed via Kepler's proprietary Nebula AI system, reportedly allowing the robot to navigate complex environments and avoid obstacles while walking across uneven terrain. Its hands can both sense and gently grasp objects, plus they allow the robot to pick up and carry heavy objects. The robot is intended for industries such as manufacturing, logistics, education, and more. Its capabilities were demonstrated in a global debut video, which sparked discussions in the robotics community. Kepler's co-founder, Debo Hu, expressed the company's vision of the robot leading to a reduced working time up to 60% per week and aiding in human space exploration because they can reduce the risk for astronauts by performing dangerous tasks in the harsh environment of space. After 3 years of research and development, the Kepler humanoid robots are expected to enter mass production and begin shipping in the third quarter of 2024. As Kepler prepares for mass production, the company emphasizes its in-house R&D capabilities and cost control measures. In addition to the robot's release, Kepler's launching a developer platform with comprehensive interfaces, projects, documentation, and tools to foster industry collaboration and promote the practical application of robotics.
So what is the final price you can buy Optimus for? Please leave your opinion in the comments section below. Thank you for watching our video. If you want to discover more interesting information about Tesla CV, don't forget to hit the like button and share this video. We appreciate your support to reach 3,000 subscribers and look forward to seeing you in the next video.